Hello, it's Dr. Bhatt from Chem here. Let us have a look on the exceptional aldehydes. What is there, why they are called exceptional, we are going to take up. And as we find from the structures, taking up two examples which are exceptional in nature, that is formaldehyde and benzaldehyde. As you find here, the the carbonyl carbon atom doesn't contain any another carbon atom which is alpha carbon atom. It is not attached to any alpha carbon atom, rather it is attached to the hydrogen atom. And therefore, the properties as expected differ from other properties, from other aldehydes, from properties of the other aldehydes, from method of manufacture of the other aldehydes. Now let us go what is abnormal. Let us view what is abnormal in these aldehydes. So here it is, the abnormal characteristics of formaldehyde. Methanol or formaldehyde behaves differently as compared to the other aldehydes. There are certain methods by which formaldehyde cannot be prepared, whereas the other aldehydes are prepared. They are available, they can be manufactured, they can be prepared. But not only this, there are special methods for preparation of formaldehyde. And these are some of the typical methods by which formaldehyde can be prepared. Now, in general, formaldehyde can be prepared by oxidation methods. A number of methods are there, oxidizing agents are there by which we can prepare. Here it is 1, 2, 3. Methanol with dichromate and sulfuric acid, platinized asbestos. These are the oxidizing agent. And at a temperature of 3 to 400 degrees centigrade, in presence of methanol, gets oxidized in presence of copper or silver to formaldehyde. Well, calcium formate on heating forms formaldehyde. And not only this, there is a special method from you can get formaldehyde by the ozonolysis of alkene. Alkene, not alkyne. It is alkene. CH2 double bond CH2O plus O3 gives formaldehyde. And you can get formaldehyde by electric discharge of carbon monoxide and hydrogen. Well, molybdenum oxide when used as a catalyst also gives formaldehyde. So these are the typical methods by which you can get formaldehyde, whereas leaving a few exceptional cases, here other methods are similar to it, to other aldehydes also. Now look at the properties of the aldehydes. The general properties of the aldehydes, other aldehydes, I mean, the physical states of the aldehyde change from liquid to the solid state with increase their molecular weights. That's why there is a variation in physical states of the aldehydes from gaseous to the solid state. But how about the formaldehyde? Formaldehyde is a gas at normal or room temperature, and it is a colorless, pungent smelling gas at ordinary temperature. It's a gas. It's not a liquid. However, it is very soluble in water, maybe because of the hydrogen bonding between formaldehyde molecules, HCHO. And actually it is like this, and it is soluble to the extent of 40%. Or in certain cases, maybe more even at room temperature. But even then, a common and easily soluble solution of formaldehyde is known as formalin, which is available at room temperature. Greater the solubility of formaldehyde is due to hydrogen bonding. Formaldehyde can be condensed to a liquid easily, boiling at minus 21 degrees Celsius. And what is typical about it, that it causes irritation to skin, nose or throat. And very significant use of it is that it served as a preservative for biological specimens such as reptiles, etc., frogs, etc. Formaldehyde is a raw material for manufacture of bakelite and urea formaldehyde resins from which we can prepare plastics. So these are some abnormal uses and properties of the formaldehyde, including the physical properties. Now let us have look at the chemical properties here. Reaction with ammonia, with concentrated NaOH, with chlorine and protein, and also phenol. Phenol reacts to form a plastic, that is polymerization. The catalytic reaction yields bakelite, a plastic, a resin. It hardens proteins. That is why we use it for uh, preservation of biological specimens. No reaction with chlorine, whereas other aldehyde containing alpha carbonatum. This is the alpha carbonatum here. That is the carbonyl group attached with a carbon which can easily give out acidic character hydrogen, and this carbon is known as alpha carbon, whereas the hydrogen which can be given for certain reaction, particularly aldol condensation, etc., is known as alpha hydrogen or acidic hydrogen atom. Other aldehydes forms a resinous product, but a 10% solution in case of other aldehydes forms a complex compound, of course unstable, and that is aldol, containing two functional groups, aldehyde group and the hydroxyl group. Now, here the other aldehydes forms an imine like this, whereas with ammonia, a very typical reaction is that it forms hexamethyl tetraamine. Formula is CH2 6 times N4. The whole reaction is given here. And not only this, there is a different reaction with Grignard's reagent. We know what is Grignard's reagent. It is RMGX, and with aldehyde, formaldehyde, you get a primary alcohol, RCH2OH. This OMGX gets attached to form a complex here, and which on hydrolysis forms a primary alcohol. Whereas in other aldehydes, you get a secondary alcohol, RCHOH, RCH3, CHOH, when we take up CH3CHO as an example. Formaldehyde reacts with phosphorus pentachloride also, but it forms dichloroacetaldehyde. That is typical about formaldehyde. And along with POCl3. POCl3 is phosphorus oxytrichloride. And then there is, of course, very important glance over the uses of formaldehyde. Boiling point minus 21 degrees Celsius, and as I have already explained you, colorless, pungent, smelling gas at ordinary temperature. It is used to form formamint, throat lozenges, for synthetic dyes, indigo or pararosilin, rongalite, used as a reducing agent in wet drying by reducing formaldehyde and sodium bisulfite compound NaHCO3, sodium bisulfite. It forms a compound like other aldehydes, but when it is reduced with zinc dust, you get rongalite, used for preparation of silver mirror. Then urotropine, we have discussed, it is formalin, is used as a disinfectant, germicide, antiseptic, preservative for biological specimens, and it hardens resonance. Then bakelite, urea-formaldehyde, and paraformaldehyde we have already discussed about it. And here is paraformaldehyde. The aqueous solution of paraformaldehyde slowly, when you evaporate formaldehyde slowly to dryness, you get paraformaldehyde, CH2OH. n times. N may be equal to 6 to 50. 100. The molecules get polymerized together and there it is a self-explanatory, quick glance at useful product prepared from formaldehyde and is significant for us. It is advised that you must go through it and keep it ready. The uh, chart here is self-explanatory, giving all details about it. Okay, thank you. We stop here and we shall be back again with some more details in regarding organic chemical reactions, maybe formaldehyde. Okay, thank you. We stop here.